Looking at this problem, we can see that it's a one-dimensional inelastic collision. So first thing we need to do for part A is to find the final speed after the collision. So we'll let M1 and V1 of I. So we're going to let M1 and V1 represent the mass and initial velocity of the SUV, while M2 and V2 will pertain to the compact car. And then we're going to apply our formulas. So our P of I equals P of F, and M1I, plus M2, we're going to do this, M1 V1I plus M2 V2I equals M1 plus M2 times the V of F. So we substitute our values for this. We get 1.80 times 10 to the third kilograms times 15 meters per second plus 9.00 times 10 to the second kilograms minus 15.0 meters per second. So we crunch those numbers, we get 1.80 times 10 to the third kilograms plus 9.00 times 10 to the 2 kilograms V of F. So switch this over, and our V of F equals to plus 5.0 meters per second, and that is A. Alright, for part V, we're finding the changes in the velocity. So first we're going to do the changes in the SUV, and then we'll do the change in the compact car. For the SUV, we have the change of velocity 1 equals V of F minus V of 1I, which is initial, equals to 5.00 meters per second minus 1.5 minus 15. Actually, this is 15 meters per second, and we get a total of negative 10.0 meters per second. So that's the change in the velocity for the SUV. For the compact car, we get change of velocity 2 equals V of F minus V2 initial equals 5.00 meters per second minus a negative 15.0 meters per second equals 20 meters per second. And that is our change in the velocity of the compact car. For the last part, we're supposed to find the change in kinetic energy of the system. So to calculate the initial kinetic energy of the system, we're going to use the formula K of E of the final first. KE of the initial equals 1/2 times M1 V1 squared I plus 1/2 M2 V2I squared equals 1/2 1.80 times 10 to the third kilograms times 15.0 meters per second squared. And when we compute all of that, we end up getting a 3.04 times 10 to the fifth. And that is our KE of our initial. The KE of our final is equal to 1/2 M1 plus M2 VF squared. So we plug in those numbers, we end up getting 1/2 times 1.80 times 10 to the third kilograms plus 9.00 times 10 to the 2 kilograms, and then 5 meters per second squared. And then when we get that, the answer earlier was in joules. Down here we get 3.38 times 10 to the fourth joules. To get the final kinetic energy of the system and to change the kinetic energy, you're just going to take your KE. It's just going to be basically your change in KE, which is equal to KE of F minus KE of initial, which when we compute that ends up coming out to be a negative 2.70 times 10 to the 5th joules. So that's our final answer for